Hi everyone, and welcome to this beginner-friendly guide on Retrieval-Augmented Generation with Langflow. In this tutorial, we'll explore how you can combine Astra DB, Mistral embeddings, and Groq with Langflow to build a powerful RAG pipeline. Whether you're new to these concepts or just curious about how they work together, this session will give you a clear, step-by-step introduction. So, what is Retrieval-Augmented Generation? Large language models, or LLMs, are powerful tools, but they don't know everything, especially when it comes to your private data or the most up-to-date information. This is where Retrieval-Augmented Generation, or RAG, becomes so useful. RAG connects a language model to an external knowledge source. That way the model can provide more accurate and context-aware answers. The process is simple. First, we retrieve the most relevant information, then we add that context to the model, and finally the LLM generates an answer. Think of it like asking a librarian for help. Before answering a tricky question, the librarian finds the right book. With that book in hand, you can give a much more accurate response. For this demo, I'll be using a fictional document from the Oakwood Community Library, a simple question and answer guide with details like opening hours, services, and events. This will help us see how the system responds to questions when it doesn't have Retrieval-Augmented Generation enabled yet. Here in Langflow, I'll start with a blank flow instead of a template. You can also use the predefined RAG with vector search template, but for this demo, I want to show it from scratch. I'm using Groq with the Gemma model, connected to a simple chat input and output. I've added a small instruction telling the bot it's a support agent for Oakwood Library. But since this model was trained without knowledge of our fictional library, it won't be able to answer correctly. Let's test it in the playground and see how it struggles to respond. Now let's build the RAG flow step by step. First, we take the Oakwood Library Q&A PDF and load it into Astra DB as our vector database. To make this possible, we create embeddings from the text using Mistral's free embedding model. This is the data load, or preparatory phase. At runtime, the user types a question in the chat. That query is sent to Astra DB for a semantic search. Astra DB returns the most relevant snippets from the PDF. We then supply those snippets to the LLM as context, and the model generates an accurate, grounded answer. That's the core loop: retrieve, augment, generate. Let's start with the data load step in Langflow. I've already added the Oakwood Library Q&A PDF using the file component. Next, I split the text into smaller chunks so embeddings can capture meaning more effectively. Then I add the Mistral embeddings component. To use this, you'll need an API key to create a Mistral account and paste your key here. Finally, I drag in the Astra DB component, which will connect to our database. I'll now show you how to set up Astra DB. Now let's set up Astra DB. When creating a new database, we choose a vector database since we're storing embeddings. I'll name mine .qa helper. While waiting, I generate a token for Langflow access, then copy it into a global variable in Langflow. Once the database is active, we create a collection to hold the embeddings. In the data in my report, I want to calculate the properties of token from the other vectors to the rooms of the database. Select a vector-enabled collection, and under embedding options, choose bring your own embedding, since we'll use Mistral embeddings from Langflow. I'll set the dimension to 1224 for the Mistral embed model, which offers high semantic accuracy. For lighter models like Mistral Embed Lite, 512 dimensions would work. Now click Create, and our collection is ready. Now let's connect Astra DB in Langflow. First, I select the database and collection from the drop-down. Next, I connect the output of the split component to the ingest data input, and the output of the Mistral embedding component to the embedding model input of Astra DB. Then I run this data loading step to let the flow process. When I check the Astra DB console, I can see the collection is now populated with embeddings. With this, the first part of our RAG system storing context as embeddings is complete. We've now completed the embeddings flow and stored our context in Astra DB. Next, we'll build the query flow. This will let us take a user's question, search the vector database for the most relevant context, and then supply that context to the LLM. Now, let's build the query flow. I start by duplicating the Astra DB component from the embedding flow. Then I connect the chat input to the search query input, and once again, supply the Mistral embedding model. To test the flow, I temporarily replace the chat input with a text input, hard-coding a query about the library's timings. Running this shows the Astra DB query results. To use those results, I add a parser component to extract the text property. Next, I connect a prompt template, mapping the parser output as context and the chat input as the question to build a dynamic prompt. Notice how I build the dynamic prompt by wrapping the variables with curly brackets. This lets Langflow replace them with live values at runtime. Now I replace the hardcode value in the text input with the actual output from the chat input. This way, the user's live question flows directly into the query pipeline. Finally, I link the LLM output to the chat output. With this, the query flow is complete. Now that we've completed our simple RAG system, let's build the flow and test the output. There was a small error in our flow that caused the build to fail. To fix it, we need to convert the Astra DB output into a data drave before sending it to the parser. Once that change is made, the flow builds successfully. Now, let's open the playground and test the chatbot. As you can see, it can now answer questions about the Oakwood Community Library without any additional training. Behind the scenes, my question is sent to the vector database, which performs a semantic search using cosine similarity. The results are then refined with Astra DB's built-in NVIDIA re-ranker and passed as context to the LLM. This means the chatbot isn't guessing anymore. It's grounding its answers in real data. For example, when I ask about the library's timings or available services, the response is accurate because it comes directly from the Oakwood Library document. What's powerful here is that I didn't have to retrain the model or fine-tune anything. I simply stored my document as embeddings, and Langflow handled the workflow. This makes it easy to adapt the same approach for other use cases, like product FAQs, customer support knowledge bases, or internal company documents. Thank you for watching. I hope you enjoyed this beginner-friendly RAG tutorial. Today we learned how Retrieval-Augmented Generation connects language models to external knowledge for more accurate answers. We explored embeddings, which transform text into vector space for powerful semantic search. And we saw how Langflow makes it easy to design and run RAG pipelines with a simple drag-and-drop interface. With just a PDF, a vector database, and an embedding model, we built a chatbot that can answer questions with real context, without retraining and without exposing sensitive data. Now it's your turn to try. Visit langflow.org and build your own RAG application. And remember, go with the flow, the Langflow.